Okay, so we are on section 14.1. We're going to work in chapter 14 until the end of the year, and you're going to have some handouts for the work for chapter 14 because it's no longer in this edition of the book. But we're going to work on matrices, and before we work on matrices, we're going to talk about some easy stuff from the past. So this is going to be an exciting, easy, simple lesson. Not new at all old. Okay, so we're going to talk about two equations and two unknowns when you have two sets of linear equations. All right, so first of all, this first paragraph talks about solutions of equations, solutions of systems of equations. A solution is a point that is on each graph, on all graphs, and that is the solution of all of the equations. So for example, if you have a line and a quadratic function, how many ways could a quadratic and a line intersect? Well, maybe, remember the graph of a quadratic is a parabola. Well, maybe the parabola and the line don't intersect. That would have 0 solutions. Maybe they hit at just one point exactly, like this line and this parabola. Or maybe they cross in 2 spots, like this line and this parabola. And so we only have 1, 2, or 0 solutions for a system of equations between a parabola and a line. Okay, but what we're going to focus on are lines, are linear equations. And so how could two lines intersect? Well, maybe they don't intersect. And so this would be no solutions. And notice in no solutions, if you have no solutions, the lines are parallel. Okay, maybe you have one solution. This is going to be what we see most of the time and what we usually think of when you have one solution. You can also have infinitely many solutions, and that's when you really don't have two lines. You really just have one line, and the other equation is the same equation of the line. It's just written slightly differently. So this is infinitely many solutions. And that's when you have your two lines, they look different, but they graph the same line. Okay, so you guys know how to solve things graphically with substitution and with elimination. We're just going to focus on the substitution and the elimination for right now. And so I have 3 examples that we're going to solve with substitution. 1, 2, and 3. And notice these are not all linear. Number 2 here has a cube. That's not a line. But we'll go through that. It's not hard. Okay, so for number 1, you have to pick an equation, and you pick a variable, and you solve for that variable. It's easy to see that this y has no coefficient, so he's going to be the simplest one to solve for. I'm going to solve the first equation for that y. Is that, yeah. So this is going to be y equals 2 minus 3x. Now in my second equation, I'm going to substitute this y in. And so I'm writing the exact equation over again, but in place of y, I substituted 2 minus 3x. So we get x equals 1. And then once you have half of your solution, x equals 1, you can go back up to the equation with the variable you eliminated, and you can replace that x with 1, and you get 2 minus 3, negative 1. And so the solution is 1 point here, and that's the point 1, negative 1. All right, on this second example, I have a cubic, like I was mentioning. And so how is that going to work out? It's going to be just fine. I'm going to solve this second equation for y equals x. And then I'm going to plug that into my first equation. And so now I just don't have a line to solve. I have a cubic, but that's okay. I can factor this. There's a common factor of an x. And now I have a difference of squares that will factor as well. And so I have three solutions, 0, 1, and -1 in the x's. And remember, y equals x, so I can find the y coordinate of those 3 points. They are 0, 0, 1, 1, and -1, -1. All right, so this one had 3 solutions, and that's because we had a cubic and a line. You can have 3 solutions there. And then finally, number 3, I'm going to leave this one to you. Solve either the first one for x or the bottom one for y. It doesn't matter. And let me do your substitutions and solve for x and y. There's a second way of solving, and this is definitely the preferred method for me and I think many others. This is called elimination. And what we do is we eliminate a letter by just adding linear combinations of the 2 lines together. So, for example, in this example here, I'm going to call this number 4. I'm going to eliminate x. I'm going to multiply this first equation by -2, and that gives me -2x minus 6y equals -8. I'm going to do nothing to the second equation. Okay, so why am I doing the things I'm doing? Well, now if I add these 2 lines together, these x's will cancel, and I've eliminated the variable x. And I get y equals -1. And now I can go back to either of the 2 original questions. I'm just going to go back to the first one. Oops, looking ahead. And so x equals 4. And so my solution here is 4, -1. I believe this way is faster. Let me leave number 5 for you guys to do, and I'll work on 6. 6 looks tricky, but it's not. Just multiply by 10. And then you probably could divide the top one by 7, maybe. So if I multiply by 10, I hate decimals. We get 63x plus 72y equals 54. 56x plus 64y equals 48. Okay, so now that I've multiplied by 10, I don't see decimals, and that makes me happier. But I can see some common factors. I'm going to take this first one, and I think everybody's a multiple of 7. So I'm going to divide this by 7. And 9. Let's divide by 9. I get 7x plus 8y equals 6. And then let's do the second one here. And in the second one, everybody's a multiple of 8. So if I divide 56 by 8, I get 7x plus, and then 64 divided by 8 is 8y equals 6. And so those are the same equation. And so if I subtract them, say, then I end up with 0 equals 0, which everybody knows. And so what happens here is that these, although they look very different, they graph the same exact line. And so this system of equations has infinitely many solutions. Infinitely many. And I am letting you do these 2 examples on your own, but if you are working at this out and you eliminate 2 letters, like I just did here, how I eliminated both the x and the y, you have 2 choices after that. If your algebra happens to eliminate both variables, either you get 0 equals 0, like I did on this case. That means infinitely many solutions. Or you could get something like 0 equals 2, and everybody knows that's not true. 0 does not equal 2. And in this case, this is when you have no solution. Okay, so if you eliminate both variables, then you either have infinitely many solutions or you have no solution. That's what happens there. And so on this last page, we're just summarizing the types of solutions we can get in systems of equations of lines with 2 variables. So 1 solution, no solutions, or infinitely many solutions. How do we know? And I kind of just went over that. We also have new words. Consistent is when you have at least 1 solution. So everything I solved today for you was consistent. Inconsistent is anything that has no solution. And that's all.